Attributes of absolute value functions. This lesson we are going to talk about the key features about the absolute value function when we graph it and things to look for. First and foremost, absolute value functions, when you graph them, are going to be in the shape of a V. It may be a V opening up or a V opening down. But for us right now, the only absolute value functions we're going to be dealing with are going to be in the shape. We're going to be doing the absolute value of linear functions. And so let's take the basic parent function absolute value of x, and we are going to create a table of values. I'm going to create an H chart of them, the middle column being my work column, x, y. And I'm just going to choose 4 numbers, a few of them negative, a few of them positive. -4, -2, 0, 2, and 4. I could choose any 4 numbers I want. I just was choosing, or any set of numbers I want. Just the big key features, I want to make sure I can, when I graph these, I come across that V, and if I don't, then I need to do some more points. And then later on, we're going to learn how to find out where that V is going to happen. And so let's take in my inputs are my x's, so I'm going to replace inside. So I'm basically doing the absolute value of each of these numbers. So the absolute value of -4 is +4. So I'm going to come over here and graph -4, +4. And I'm just putting a dot there. And the absolute value of -2 is +2. You may at this point not have to actually do a table. You may be seeing the pattern, but I'm going to continue it on throughout all these points. Just so that we can have a good set of values. And so absolute value of 0, 0, absolute value of +2 is 2. As you can see at this point, we're starting to see that V form. We've gone down and now we're starting to go back up. And the absolute value of +4 is 4. I am going to connect my dots and draw in the lines. I usually start from what is called the vertex. That's where that V is pivoting from. And then we're going to go up the other side. And that makes the absolute value function. So let's talk about some key things of this absolute value function. In this, my domain is going to be from -infinity to +infinity, aka all reals. My range, though, I am not going to cover all my y's. My stopping part of the y's is here. So I have nothing below 0, but I do include 0. So my lowest value for y is 0, and I go until I'm at +infinity. If we wrote it in just inequality format, that'd be y is greater than 0, greater than or equal to 0. but writing it in interval notation is that first one. And we're going to be writing our domain and range often in interval notation. Okay. Other key features of this absolute value function is it's symmetric. That means I can fold it across itself, and if I fold it over the line y equals 0, so I mean y equals 0, I said that backwards, sorry, this must be x equals 0 is my line of symmetry. That's this line right here. This point here is called the vertex. My vertexes in this problem is at 0, 0. And if I asked you for, actually let's go on to this next one real quick, and I'll go back to that. Let's again do a table of values for this. And again, I am going to choose 5 points. -4, -2, 0, 2, and 4. This is my work area. Or you could use those function rule papers that we have, or the function machine papers. So these are my inputs. This is what goes in. This is my outputs. This is what comes out of the function machine. This is your x. This is your y. So we have the absolute value of -4 minus 1 plus 2. So -4 minus 1 is -5. And I take the absolute value of that, that gives me +5. Plus 2 is 7. I'm going to go ahead and take and calculate each of these before we go over and graph. The absolute value of -2 minus 1 plus 2 gives me a -3 that I'm going to take the absolute value of, so that's going to be a +3 what comes out, plus 2 is 5. The absolute value of 0 minus 1 plus 2, so the absolute value of -1, which is 1, plus 2, 3. Now I'm going to go to 2. The absolute value of 2 minus 1, which is 1. The absolute value of 1 is 1 plus 2 gives me a result of 3. The absolute value of 4 minus 1. 4 minus 1 is 3. 3 plus, the absolute value of 3 is 3. Plus 2 is 5. Okay, I am going to go over to my graph, and I'm going to graph those points. -4, 7. So 1, 2, 3, 4. Up 7, 1, 2, 3, 4, 5, 6. 7. 2, 5. 0, 3, 2, 3, 4, 5. So if I look here, I can see that it is going down and back up. I am going to have to draw in my lines, and I'm just going to take and use my line to kind of fill in the pieces. Well, I can't really see where my V is, but if I take and extend on down here, I can see that those would meet up at the same point, and that point is 1, 2. And if I actually try the point 1, I can see that 2 comes out as the result. So this is my absolute value graphed. So now my vertex of this graph is there, which is at 1, 2, or 1 for my x, 2 for my y. My line of symmetry is here, and the equation of that line is x equals this x value. So x equals 1 is that line of symmetry. That is the line in which I could fold it across. So on here, another point I can pull out is my y-intercept. Which is at 0, 3. There are no x-intercepts, because I do not cross the x-axis. The graph has a domain from negative infinity to positive infinity, because there's all the x values I can plug in. A range, my lowest spot I can be at for my y's is where that vertex is. And so my lowest point is at 2, but I can go all the way up to positive infinity. Now, we're going to take that same function, and I want to take it a step further. So we're going to take that function f of x equals the absolute value of x minus 1 plus 2, and we're going to answer one more question. And I'm just going to throw this on here. What if I wanted to know the minimum on the range from negative 3 to positive 10, and the maximum? I want to find the min and max. When we dealt with linear equations, the min and max were these 2 points only. One of them had the min as a result, and one of them had the max. But if you look back at our graph, we see that that's not going to be the case here. The lowest point of my graph is at the bottom of that V. So this point is my lowest point of my graph. So my minimum value is at that vertex. And in this case, we found that my vertex was at 1, 2. And so my minimum is at the y value of 2. And we always go off of the y value. And I can come back here to my graph and find that minimum. And maximum, I'm going to try out both those values. And so I'm going to check out what is f of negative 3. It's the absolute value of negative 3 minus 1. Plus 2. So the absolute value of negative 3 minus 1, so that's going to be negative 4 plus 2. So the absolute value of negative 4 is 4, which is 6. And so now I'm going to test out the point of positive 10, so f of 10, and so I'm going to plug that into the absolute value equation, which was the absolute value of 10 minus 1 plus 2 is the absolute value of 9 plus 2. Absolute value of 9 is 9. 9 plus 2 is 11. So my maximum point is this one. So my max is at 11. So my lowest y value for that section, and remember that's just us restricting our domain to that section and looking at only that section on the graph. So my min is 2, my max is 11. And I don't think I actually graphed it where you could see the 11, but if you were to continue that graph on farther, you could see it. So my min is 2, my max is 11.